Okay, so this problem says USA Today reports that exactly 5% of US adults have seen an extraterrestrial being. All right, great. Suppose you test this claim and poll a random sample of 250 adults. If 8% reply yes, I guess yes that they've seen an extraterrestrial, is there enough evidence to reject the claim at 1% level of significance? All right, so let's get a space to work on here. Okay, so what kind of problem is this?
A two-tailed.
Two-tailed, well, first,
hypo-
two-tailed what? Yeah, hypothesis test, right?
Yes.
How do we know it's a hypothesis test? Because we're trying to test what? We're trying to test some kind of a claim, right?
Yes.
And also, too, down here, see down here where it gives us this level of significance, that's another giveaway as well, too, because when you talk about significance tests, that means you're talking about a hypothesis test. All right, so for a hypothesis test, what kind of stuff do we have to get? We have to figure out what the null hypothesis is. That's the thing we're trying to establish. That's the claim we're trying to establish. And then also the alternative as well, too. So let's write down H0, and we'll think about what that is, and also HA. That's the alternative. And then the way we're going to test this null hypothesis up here is to compute a sample proportion and a test statistic. And then from that, we'll look up an area, and that area will tell us whether or not we believe the null hypothesis. And that area is called a p-value. All right, so let's see what they're trying to, what kind of hypothesis test it is here. So it says that USA Today reports that exactly 5% of US adults have seen an extraterrestrial. So that, I think, is giving me the population proportion I want to test, right? What is the population proportion I want to test?
5%.
Yeah, 5%.
0.05.
Yeah, so I'm going to label that theta as 0.05, right? That's the thing we want to test. And now it says, suppose you test this claim and pull 250 adults. That's got to be what? That 250 is what?
That's your sample.
Sample size, yeah.
Yeah.
So that's n. So 250. That's what label that as 250. And it says if 8% reply yes, is there enough evidence to reject the claim, this H0 up here, at 1% level of significance? So this 1% down here, the notation we used for that was alpha. So let's label that as 0.01, right? 1%. All right, now let's see. What is this 8% right here telling me? What is that?
That's your alternative hypothesis?
Well, actually, this is, I don't think it's an alternative hypothesis, but what it is the test statistic, right?
Oh, yeah.
This, I think this is this corresponds to the sample proportion that comes from this 250 adults. So that's not directly the alternative hypothesis, but it kind of gets used in a little bit as the test statistic. I think up here, to get the alternative, I have to look up here and see exactly what it's saying about this population proportion. USA Today is saying that it's exactly 5%. So if I want to test that claim, that could be false if it's either bigger than 5% or smaller than 5%, right?
Mm-hmm.
So that could be, in order to test that, I think I'm going to have to make the alternative just different from 0.05, right? In either direction. So if it's too big, then we'll find against the null hypothesis, or if it's too small, we'll find against the null hypothesis as well. This is called what kind of test? When you're testing to see if a population proportion is different from some value.
Two-tailed.
Yes, two-tailed. Okay. And we'll see where that comes in a little bit once we draw our sample proportion and the test statistic. All right, so let's see. So we're going to draw some pictures here. So let's draw the p-hat distribution here. That's the distribution of sample proportions. And in the middle of the p-hat goes the mean for this thing. And in this case, what's the mean for this thing? Also, it's the population proportion we want to test, and that's theta as well. What are we testing here?
0.05.
Yeah, 0.05. So I think that's going to go right there in the middle like that. And now let's see, we're going to change these guys into z-scores. So let's put z over here. Okay, so what's in the middle of the z curve over here?
0.
0. So and that corresponds to this 0.05 over here, right? Okay. Now, where's our sample proportion? Our sample proportion is what? This 8% right here, right?
Mm-hmm.
Now, where's the 8% compared to this 0.05 here? To the right or to the left of it?
To the right.
Yes, to the right, right? So it's over here. So I'm going to label this as 0.08 right there. All right, so we know that this guy is going to turn into a z-value over here that's going to be what? What kind of z-value? Positive or negative?
Positive.
Yeah, positive, because z-values over here are positive and z-values over here are negative, right? Okay, so we're going to have a z-value over here, about right here that we're looking for. Let's put a question mark right there. Now when we're finally done, what we'll do to get our p-value is we'll look at the area of these tails out here, right? One tail to the right of this z-value up here is going to be this guy over here. But because we're doing a two-tailed test, I also have to come back over on the other side, and exactly the same distance on the other side of 0, I have to pick up the area of the tail over there as well too. Okay, so once we get the area up here, we'll be able to figure out what the p-value is by doubling that area. Okay, so let's go. Let's see how we're going to compute this z-value over here. So that's called the test statistic, and there's a formula that gives us that. What's the formula?
Data minus the mean.
Minus mean, right?
Divided by the standard deviation.
Divided by the standard deviation, right? Perfect. Okay. So let's see. The data in this case is what?
That would be...
What's the mean? Let's start with the mean. Where's the mean here?
It would be 0.05.
Yeah, that's the 0.05. So the data's got to be the other thing, right?
The 0.08.
Yeah, the 0.08. Perfect. Now, the standard deviation, how do we figure out the standard deviation down here?
It is...
I think there's a...
Yeah,
you got to have a formula for it, right?
So
and what's the formula? Do you remember?
It's 1 minus the mean.
Yeah, there's 1 minus the thing that we're testing here is this 0.05. I'm just going to put it in. It's 1 minus there's okay, so that goes on the top there, but there's another part over here as well too.
The 0.05.
The 0.05, that's right. So it's the mean times 1 minus the mean, and then I got to divide by
n, which is 250.
250, good. Okay. Let's put that on. Okay, so we're going to need some calculator work here, and I'll tell you what it is. Hang on a minute. So it's going to be 0.05 times 0.95, and then divide by 250. So get that first. And then when you're done with that, take a square root of it.
.013.
Is that after the square root?
Mm-hmm.
Okay, 0.013. Okay, so let's round that one up. 138. Let's put that down here. 0.0138, and I'm going to ask you to do another calculation. 0.05 minus 0.08 minus 0.05 is 0.03, right? And divide that by 0.0138. Tell me what you got.
2.17.
2.17. Okay. 2.17. What's the last digit there? 3. Okay, so let's round off to 2 decimal places for the z-value. That means this guy up here, the z-value we're looking for, that corresponds to this 0.08, that turns out to be 2.17, right? Mm-hmm. Okay, now, to find the p-value, what I have to do is I have to look up the area to the right of that z-value and then double that, right? Because I have another tail over here that corresponds to the same shape, but just on the other side. So let's find the area here. Is going to be, now if it's an area to the right of a z-value, how do I get that area? I can't just look up that area in the table. I have to do what?
Would be 1 minus.
Yeah, 1 minus. So the area that we're looking at to the right of 2.17 is going to be 1 minus, so now let's do our table lookup. And the table lookup is going to be 2.17. Okay, so give me those values.
So it's 1 minus 0.9850.
That's right, 9850. So go ahead and subtract that and give me that area.
We get 0.015.
0.015. Okay, so that's the area of this right tail right here. So let's write down our p-value. The p-value is going to be 2 times that because it's this tail over here as well too. So I'm going to take 2 times 0.015, and that's going to be about what? 0.03, right? Okay, so that's our p-value. Now what do we do with the p-value?
You have to see how significant or not it is, compare it. You have to find a conclusion.
Yeah, we have to find the p-value. We go directly from the p-value to the conclusion. Now, if you don't have a level of significance to work with, what you do is you take the p-value and you look it up in that table that tells you how strong the evidence is against H0. So the smaller the p-value, the worse it is for the null hypothesis. If you find a very small p-value, then that leads you to reject the null hypothesis. If you don't have but if you do have a level of significance, though, we have one, this 1% over here, then what you do is you take this p-value and compare it to that, right? So in this case, our alpha, we said, was 0.01. And since the p-value is what? The p-value, is this p-value smaller than this alpha or not?
It's larger.
It's larger, right? So this means that we can't reject the null hypothesis, right? So here, if this p-value had been smaller than this 0.01, then we would reject the null hypothesis up here. But in this case, because the p-value is larger than alpha, we can't reject. And the way people say that is they say, you failed to reject H0 at this level of significance. And you also say that the result is not significant. Okay, so this is not enough evidence for us to conclude that the USA Today was not telling the truth, right? It looks like our conclusion up here says that we don't have enough evidence to dispute the claim by USA Today. Got it?
Got it.